The point of today, we're painting a picture. It's a big picture. And the act of writing software, the act of authoring code, the act of designing systems, the act of building frameworks is ordered, sequenced, access to state. That's it. It works, stuff gets reordered all the time, and we don't care because we don't notice it. It's orthogonal to what we do. And what we do is sequenced access to state. Okay, so the goals of today, we have this as-if rule. That's kind of like the final blessing by the language standards saying, yeah, reorder all you want. As long as intent is respected, we're good. Control flows, data flows. This is what the compiler is doing. It's what the CPU is doing. And we're going to talk about that a lot today so you get comfortable with it. But this imperative versus sequential device contrasts that. Reordering is a good thing. And what's really nice is once you have an appreciation for you don't really care about instruction ordering at all, you can be more flexible in your reasoning. You specify less. You do less work. You give more authority to the compiler and the CPU. You do less. And your systems will be less brittle and will scale better, which is ultimately the goal. So your statements did execute correctly. The way you specified it was respected by the compiler, respected by the CPU. It executed that way. Your algorithm ran correctly. You might have a surprising answer. You might not be happy with your surprising answer, but your algorithm executed correctly. So any errors are entirely errors in our failure to specify the dependencies. We love our compiler. Our CPUs are fantastic today. We should really use them. Who knew? And then it's our job to design and implement based on dependencies. Sequenced access to state. All our systems have assumptions. These things, this is why the software industry has a hard time scaling. We put assumptions in there that we're unaware of. And when we become aware of them, we fix them, we address them. Ideally, we would address them in the design early up. So there is no guarantee that your statements will execute in the order you specify in your source code file. We have statements, we have compound statements, little block things. We scale up and we author our systems using language rules, but this reordering thing, it's going to happen because it's orthogonal to what we do. There are compilers optimizing stuff. They can't help but not. There is CPU pipelining stuff, and this cache subsystem is going to introduce latencies, and we're going to have to address those. But that's okay. We're cool with this. It's been reordered all the time. We don't even notice. We don't care because it's orthogonal to what we do. Any order that respects logical dependencies is logically equivalent. Code mobility is totally fine. Move all your assignments to the bottom, all your declarative stuff to the top, or not, intersperse them, that's totally fine. Any order that respects your logical data flows, control flows, that's the same program. And this statement is actually the only reason the compilers work. If you did not have this to be true, the compilers and the CPUs couldn't possibly do their jobs. And that's it.
Thank you very much.
Thanks.